Good afternoon, Dr. Zidia. This is Group 7's presentation. My name is Qiao Mengting, and my group members are Li Honglin and Cui Evan. I will cover the problem, the data, the model strategy sections. So let's just start it. Here is our structure. Project 1 covers the problem, data, and the model design. Then we move to the Project 2, implementations, and our final recommendations. I will handle the first part. So our project predicts first payment default, FPD. This means a customer misses a very first repayment. It is the earliest warning sign for the credit risk. So the system converts a predicted FPD probability into 3 decisions: approval, manual review, and reject. The goal is to catch risky applicants early, reduce the bad debt, and avoid rejecting good customers. That is why we need the 3 tiers, not just approve or reject. So we have 5 groups affected: the institution, customers, risky team, credit offers, and regulators. Each has different needs. The institution wants strict control. The customers want the fair treatment. The conflict is why the manual review rule exists. So it balances the risk and fairness. Our dataset has 38,985 rows and 87 columns. 85 anonymized features, 1 ID and 1 target. Target equals 1 means FPD, target equals 0 means no default. So the key number is the FPD rate, only 2.89%. This is a several class imbalance. A model that labels everyone safe gets about 97% accuracy, but catches 0 risky appliance. This is why we don't use accuracy, we use recall the precision and PRAUC instead. All features are anonymized, so we interpret them as risky signals only, no unsupported business claims. Project 1 planned 5 pre-processing steps, remove extremely high missing features. For the rest, using missing indicator plus media imputation. It code the Boolean columns to 0 and 1, apply the standard scalar only to logistical regression, and use class weighting to handle the 2.89% imbalance. Project 2 validates all of this with actual results. We use 3 models. The logistic regression is a baseline. Transparent, auditable, directly give a probability. Random forest is an alternative. Captures nonlinear patterns but less interpretable. XGBoost is a benchmark. Strongest performance but highest governance cost. So the logic is simple. Start with an explainable baseline. Test whether complex models improve FPD detection. Then select the final model based on the actual metrics and business constraints. Recall is our top priority. Missing a real FPD case means approving a risky client that leads to the bad debate. Precision controls unnecessary rejection of good customers. F1 balance falls under class imbalance. The confusion metric connects errors to business impact. PRAUC is more reliable than ROC-AUC under a several imbalance. So accuracy is only a reference. It is misleading here because non-FPD classes dominate. So that's all my part. Thank you. I will pass it to Li Honglin.
Hello, Doctor. My name is Li Honglin, and I will present the transition from Project 1 design to Project 2 model validation. And this slide shows the 3-tier decision rule designed in Project 1. And the predicted FPD probability is converted into 3 decisions: approve, manual review, and reject. and then no risk group is approved, and the middle risk group goes to manual review, and the high risk group may be rejected or blocked and with peer review. And the key point is that these thresholds were only initial designed thresholds, and they were not final optimal thresholds. And so Project 2 needed to validate them using actual model outputs. And this slide summarizes the main risk before implementation. And the most sensible risk is false negative, meaning actual FPD customer is approved, and this may lead to bad debit. So recall is prioritized. And false positive means a good customer is warranty rejected, and which may cause income loss and fairness issues, and manual review help reduce this risk. And there are also collaboration risk and interpretation risk. And collaboration risk means predicted probability may not equal actual default probability. And interpretation risk comes from anonymized futures. And the key conclusion is that this system should only be used as a decision support system and not a full automated leading system. And this slide connect Project 1 and Project 2. And Project 2 and keep the same FPD problem and Kaggle dataset and target variable and the three-tier decision structure. And the actual data conform the two main problems and several class imbalance and missing values. And this explains why accuracy is not enough and why preprocessing is necessary. And they planned models logical regression and Randolph forest and XGBoost and were implemented, and the original threshold was also tested and later revised. And so Project 2 many validation Project 1 and updates what failed in practice. And this slide shows the proposing results. And first, the ID column was removed because it is not a gradient risk signal. And second, high missing features were removed, and four remain missing values. And the missing and indicator columns were created, and the media imputation was applied. And 5 Boolean features were converted into 0 and 1 format. And after preprocessing, and the final input had 114 features, and including original usable feature and missing indicator features. And the data set was then split into training and testing set user stratified split, and so the FPD rate was preserved. And this slide summarizes the model implementation. And the model was implemented logistic regression as a transparent baseline and Randolph forest as a non-linear alternative, and the XGBoost as a performance benchmark. And because FPD cases unreal imbalancing handling was necessary, and logistic regression and Randolph forest used the class weight equal balanced. And for XGBoost, schedule pulse weight was used to give more weight to manipulate FPD classes. And after training, and the model product FPD probability scores for evaluation and threshold testing and decision revision. And this slide shows the first evaluation using the conventional threshold of 0.5. And this threshold is not the final business rule, and it only shows initial model behavior. And Randolph forest has a highest accuracy, but its FPD recall is 0, and this means it misses all actual FPD customers. And the logistic regression has the highest FPD recall, but its precision is low. And XGBoost has slightly higher precision, but it still misses most FPD customers, and therefore the model cannot be selected by accuracy alone. And FPD recall is a priority metric. And this slide explains the confusing matrix results, and the logic regression detects more FPD case, but it also created many false positives. And Randall Forest predicts all test applicants are non-FPD, so it miss all risk FPD customers. And XGBoost detect only part of the FPD case and still misses many actual FPD customers. And so they confuse metrics shows the real business errors behind the metrics. And the next, this net shows the ROC, AUC, and PR AUC results. And the ROC, AUC value are closed across the three models, and the PR AUC values are no because FPD cases are real, and this means all three models have only fixed to moderate reaching ability, and therefore the model should not be used for automation, and they should support the decision making with threshold rules, manual review, and human oversight. And finally, this slide explains model interpretation and filter importance and the shape were used to identify predictive signals. And however, the filter are anonymized, so we cannot say the represent income transaction history and employment stability or business causes, and therefore SHAPE can support transparency, but interpretation must remain at the model and the decision level. And to conclude my part, and project 2 shows that model performance alone is not enough. The final business decisions still depend on the thresh testing and collaboration and operational constraints. And next, we will examine whether the original project 1 thresholds can really support credit decisions. And thank you. This is my part.
Good afternoon, Dr. Zaidi. My name is Chow Ivan. In this presentation, Chow Mong Ting covered the first payment default FPD background business problem dataset and Project 1 foundation. Li Hongling covered the decision rule, Project 1 to Project 2 linkage, pre-processing, model implementation, and initial evaluation. My role is to explain the problems found after implementation, threshold revision, and final deployment recommendation. In Project 1, we use two initial thresholds, which is 0.03 and 0.1. Applicants below 0.03 were approved. Applicants between 0.03 and 0.1 went to manual review, and applicants above 0.1 were rejected. After testing this threshold in Project 2, we found that the three-tier structure is useful, but the fixed threshold failed. Logistic regression was too strict and rejected 99.49% of applicants. Random forest was too loose and missed 45.6% of FPD cases. XGBoost control risks strongly, but rejected 75.45% of applicants. Therefore, the original threshold cannot be used directly. Next, system failure analysis. Issue came from three areas: data, model, and decision rule. For data, the FPD rate is only 2.89%. 37 features have missing value and the features are anonymized. This makes accuracy misleading and limits feature level explanation. For the model, class weight and scale cross weight help handle imbalance, but they may distort probability score. So model score cannot be treated as true default probabilities. For the decision rule, the same threshold gave very different results across models. The calibration curve also shows that predicted probabilities are not fully reliable. Therefore, the three-tier ideal did not fail. the fixed threshold and calibration reliability failed. Next, division revision objective. After identifying the problem, we revise the decision strategy. Our final choice is to prioritize reduced FPD risks while still controlling customer friction. This is because approving actual FPD applicants may create early default loss. However, customer friction is controlled using reject rate limits, manual review caps, and appeal mechanism. Therefore, the revised strategy balances risk control, workload, and fairness. Next, cost-weighted threshold tuning was the first revision we done. The cost function was in this formula. False negative has the highest weight because approving an actual FPD applicant is the riskiest outcome. These weights are relative business assumptions, not actual bank costs. Cost tuning reduced model costs. For example, logistic regression decreased from 30,094 to 5,769.6. However, it was not selected as the final rule because manual review became too high, which is 72.16% for logistic regression, 83.08% for random forest, and 80.53% for XGBoost. Therefore, cost tuning is useful only as a diagnostic step. Next, business constraint threshold search. Because tuning creates too much manual review, we use business constraint threshold search with 5 red lines. Review plus reject recall must be at least 70%. Reject rate must be between 1 and 20%. Manual review rate must be under the 40% strict cap or 50% relaxed cap. Approved default rate must be below 2.89% base rate. Reject precision must be above 2.89%, preferably 4.34%. The 4.34% means the reject group should have at least 50% higher default rates than the average applicant 2, which is times 1.5. This red line convert Project 1 risks into Project 2 operating rules. Next, feasibility under manual review capacity. Logistic regression is the only model feasible under the strict 40% manual recap with final threshold of 0.43 and 0.59. Random forest and XGBoost can capture more FPD cases, but they require the relaxed 50% cap and create higher operational pressure. Therefore, logistic regression is recommended because it is more feasible and easier to explain, audit, and govern. Next, final decision metrics and business impact. For logistic regression, 63 out of 226 actual FPD cases are still approved. However, 84 are sent to manual review and 79 are rejected. This means 163 out of 226 FPD cases are controlled through manual review and reject. The review plus reject recall is 72.1%, meeting the 70% target. This model does not remove all risks, but give a more balanced decision outcome than the original threshold. Final recommendation and deployment decision. The recommended model is logistic regression with final threshold of low, which is 0.43, and high, which is 0.59. It is selected because it meets the strict 40% manual review cap, keeps the approved default rate below the base FPD rate, preserves a meaningful reject trail, and is easier to explain and to govern. If we are personally accountable for the system outcome, my answer is yes, but only as a control decision support system. The system cannot be full automation. So the human oversight, monitoring, fairness check, documentation, and appeal mechanism are still needed for control decision support system. In conclusion, Project 1 three-tier design is validated, but the original 0.03 and 0.1 threshold must be revised. Project 2 shows that accuracy and fixed threshold are not enough under severe class imbalance. The final strategy use business constraint threshold and logistic regression is recommended for control deployment. The system should support credit officers but not replace them. That's all for my part. Thank you, Dr. Zaidi, for listening to our presentation.